Okay, so where are we at in our fun little trip in chemistry? Okay, what you need to remember is our ultimate purpose is we are trying to locate electrons in atoms. At this point, we have done these four ways. We have used quantum numbers, we have then used orbital notation, and orbital notation is with the lines and arrows, okay? And we've used electron configuration notation, and that is without the lines and arrows. And then we have used electron dot notation, where we've been putting dots around elements. And what you need to realize is our ultimate goal is to look at atom stability. Now, I'm going to talk fast here, so if you need to take notes, or no, actually you will take notes, you're just going to need to pause the video if you need to write things down. So we want to look at how do atoms become stable, okay? And that's one of the things that has always been in the background here is atoms are always trying to reach stability. So this should really be the first thing that you write down in your notes. Okay? It's literally why elements react with each other. Okay, our ultimate goal here is we want to get into chemical reactions, and we are itching to get there. Okay, we are very close now to getting into chemical reactions because we have to look at what they are trying to do. Okay, and they're always trying to reach stability. Okay, so what is stability? Well, chemists have found out that atoms are stable when they have full energy levels. Okay? And those full energy levels turns out to be their orbitals. And so when does that occur? And one of the things that you'll probably have noticed is every time we fill an s and a p orbital, so when I fill an s orbital, which has 2 electrons in it, and I fill a p orbital, which has 6 electrons in it, okay, we have gone to a new energy level. And that is an octet, okay? So essentially, stability occurs when we have an octet. And an octet is 8 electrons in a full level. And those 8 electrons happen to be filling an s orbital with 2 electrons and a p orbital with 6 electrons. So that gives us a total of 8. And you'll notice even when we were working with electron dot structures yesterday, we only worked with 8 electrons. Okay? Now, when does this occur? Well, it always occurs at the noble gases, which is group 18 of the periodic table. And we've talked about this many times in class, that one of the unique things about noble gases is they tend to be non-reactive. Okay? Now, in recent years, we've actually forced some of them to react, but mostly they are non-reactive elements. In fact, they are so non-reactive that they were actually some of the last elements to be discovered. Okay, so because of that fact, okay, so then that's when chemists started realizing that, hey, we like to get to this octet configuration. Okay, now, chemists also found that stability occurs for some reason with half-full orbitals. Okay? So, if an orbital is half-full, that also created stability. So like a p orbital, if that were half-full, or a d orbital, if that were half-full, for some reason, that creates stability in an atom. And essentially what all of this does is it leads us to this fact. Okay? All atoms want to gain or lose electrons to try and reach this octet. That's what they do. Okay? So because they do that, one of the things that we're going to look at is the electron configurations of these elements. Okay? So if you look at the configurations of these elements, it actually helps us to see how they do this task. So that's what we're going to look at. We're going to look at electron configurations of ions and figure out how that happens. So remember, an ion is just an atom that has gained or lost electrons. Okay? So let's start with a lithium ion. Okay? Now, I'm going to start with normal lithium. Okay? And if I start with normal lithium and I look at its electron configuration, okay, it is in the second column and it's the first element. So its electron configuration is 1s2, 2s1. Okay? So that's normal, neutral lithium. It has 3 protons, 3 electrons. Okay, right here, those are its 3 electrons. Okay? Now, as you can see right here, lithium likes to become a 1+. Well, remember, we talked about ions. If you become a 1+, the way you do that is you lose an electron. Well, if lithium loses this electron, then it keeps 2 electrons. So it has 3 protons, and now only 2 electrons, because it got rid of the 1. It's now a 1+ ion. Perfect. Well, it now has the electron configuration of 1s2. So what noble gas does it look like? And the noble gas that it looks like is helium, because the electron configuration of helium is 1s2. Now, this is the one exception to the octet rule. Okay? Everything else is going to be an octet, but this one happens to be stable without being an octet. But that's how it became an electron, or a 1+ charge, okay, is it lost that electron. Now we'll get into some that will be octets. So let's look at magnesium. Okay? And I'm always going to start with the normal element. Okay? So normal magnesium is 1s2, 2s2, 2p6, 3s2. Okay? It's in this third energy level. Okay? Now, in order to become a +2 charge, okay, that means that it has to lose 2 electrons. Well, of this grouping right here, which 2 will it lose? Well, in order to get an octet, it's going to get rid of those 2. That leaves this, which happens to be the electron configuration of neon. And that gives us our octet, because we have our 8 electrons in the highest occupied energy level. So that means the electron configuration of Mg plus 2 is 1s2, 2s2, 2p6. So that's Mg plus 2. So why isn't this now neon? Okay, and what you have to realize is, and this is huge, the number of protons has not changed. And this goes back to when we talked about protons are what actually determine the type of element. And since protons don't change, it still remains magnesium, even though in its electron configuration it looks like neon. So it's happy, okay? And that's one thing that I'm going to say is that the group 18 elements are essentially the cool dudes. I don't know how to spell dudes. The cool people of the periodic table. And everybody is trying to look like them. Okay? So, let's just keep going. Now, if I look at fluorine, fluorine is 1s2, 2s2, 2p5. Okay? Now, this is normal fluorine. Okay? That's what its electron configuration will be. But then you need to realize, what does this 1 minus mean? And that means it gained 1 electron. Okay? So this is going to pick up 1 extra electron. So then the electron configuration of fluorine 1 minus will be 1s2, 2s2, 2p6. That is now its electron config. And who does it look like? Okay, and again, it looks like neon. Why isn't it neon? Right? And you got to remember, number of protons has not changed. Okay? And then do we have our octet configuration? Sure. We have 2 electrons and 6 electrons. That is 8 electrons. Okay? So our octet configuration has not changed. Okay. Let's just keep going here and look at some others. So let's look at oxygen. Normal oxygen is 1s2, 2s2, 2p4. Okay? The 2 minus means we gained 2 electrons. So I'm going to pick up 2 electrons. Okay? Well, if it picks up those 2 electrons, then now it looks like 1s2, 2s2, 2p6. And again, now it looks like neon. Okay? So this is what's happening with elements. They're just trying to lose or gain electrons. Okay, so we can go to aluminum. We're going to do just a few more. Normal aluminum, okay, is 1s2, 2s2, 2p6, 3s2, 3p1. Okay, so now you got to go back to what does plus 3 mean? And that means we lost 3 electrons. Okay? Doesn't matter where they come from. I have 3 electrons right there. 1, 2, 3. Okay? So if I lose those 3 electrons, then my electron configuration comes back down to looking like neon. So the electron configuration of aluminum 3 plus is 1s2, 2s2, 2p6. We no longer have those electrons. They are lost. Okay? They're not really lost though, because they are probably going to, not even probably, they are going to some element that is going to pick those 3 electrons up. Oh, maybe an element like phosphorus, okay, that wants to pick up 3 electrons. Okay, so if I get to phosphorus, okay, normal phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Okay? So phosphorus is short 3 electrons. So if it can pick up 3, so that means it gains 3 electrons. So if it can pick up 3 from someplace, then it becomes a 3p6, and that becomes stable. So phosphorus 3 minus is 1s2, 2s2, 2p6, 3s2, 3p6. Okay? And now we look like a new noble gas that we haven't looked at before, but it's still a noble gas. It's still argon. Okay? So phosphorus now looks like argon in its electron config. And that's one thing I'm going to say a lot, is it looks like argon. It's not really argon. Okay? So, this is electron configurations of ions. Now, what happens is this gets a little bit tricky when you get into some other elements. Okay? I don't want to do that yet. I got to back up. Okay? And you just have to play around a little bit. So if I look at iron, okay, iron can be a +2. But if you look at the electron config of iron, it's in the D block. So I'm actually going to do shorthand notation for iron. So the electron config of iron is Ar, and then it is 4s2, 3d6. Okay? So this is its normal configuration. So this is what it would normally look like. Okay, now, iron likes to form a +2 charge. Well, how would it do that? Well, you can see right here that, you know what, there's a 4s2. So if it gets rid of those 2 electrons, then it becomes Ar 3d6. Okay? But the one thing that you'll notice in the periodic table is iron actually also likes to form a +3 charge. Okay? So how would it do that? If normal iron is Ar and it is 4s2, 3d6, well, it needs to get rid of 3 electrons. Well, if it gets rid of those 2 and gets rid of one of those, that's 3 electrons. So then the Ar or the Fe3 plus becomes Ar 3d5. And there's one of those cases where stability occurs because you have half-full electrons, or half-full orbitals, excuse me. Okay, so we have half-full orbitals there. Okay, this is getting a little bit longer than I wanted to. Your worksheet, okay, is going to have you working on these. But for attendance purposes today, okay, here's what you need to submit to me. You have a worksheet that is attached to this assignment. You need to complete that worksheet. But for attendance and watching this video, you need to identify the elements that I have below, and you need to submit those to me via Google Classroom. Create a Google Docs and answer these 10 questions and send them to me. Okay? So all you need to do is get a periodic table, locate each one of these elements, and tell me what they are. Okay? So this is identifying an element. I want you to tell me what element it is identifying. Same with these. These are identifying elements. Okay? I want you to identify those elements and tell me what they are. There's 10 points here. Okay? So if you need to pause this video at this point, oops, excuse me. If you need to pause this video to answer these questions, then do that. That is your assignment.